I was coming to you next, so perhaps you can talk to some of that. But I'd love to understand sort of uptake of AI that you're seeing in your work, and where the sort of applications of the concentration of applications coming from.
Yeah, thanks, Emma. So there's a broad range of applications that are really starting to surface in our business. We work a lot with cities, government, central government, federal government, also utilities, all of whom have been pretty adept at working with structured data, you know, temperature settings and measurement data that's always been around. What's been difficult, I think, has been dealing with unstructured data, so video, text, audio files, even large-scale photography, aerial photography, surveys, which have typically just been used for sort of reconnaissance work, perhaps, and sort of building anecdotal information. With AI, with machine learning, particularly deep learning, there's the ability to take those unstructured data streams and actually start to apply them to deep learning models to generate new insights. So the work we're doing with MFE around deforestation is surveying a large part of the country, about 7,500 forested blocks that have been alerted to potentially have been deforested or land use may have changed. And this is in order to really drive a broad view of the picture of carbon net loss or gain from the forestry sector. So we've trained, we're in the process of training a model to interpret those images and to determine a dominant land cover, and potentially whether that forest block has been converted. Now, in the past, that required, you know, human observers, either from aircraft or from photos, actually making a decision on an image. A very laborious, time-consuming task. So we're going about a process of building a model which will really have long-term payback, which will allow mostly automatic classification of the entire deforested area. So in terrestrial systems like forestry, cities looking at changes in land use, particularly, for example, as it relates to water quality or stormwater planning, we are also doing a lot of work looking at forensic sort of impervious surface detail, looking at bare earth across catchment, and even down to things like looking at roof material and condition, rusting roofs and so on, and how does that relate to water quality. Also in the marine space, we're doing quite a lot of work looking at fish detection and observing fish in motion to classify species and look at overall health of species. So I'd say machine vision overall as a summary is really the hot area right now that's showing a lot of promise and a lot of potential sort of early stage value for organizations.
Thanks, Matt. I find that fascinating. I've spent some time in machine vision for fisheries around fish recognition and so on. Just out of interest, have you been using drones for some of your footage? Yes, we have.
Fixed wing aircraft tends to deliver a very broad, reliable view with a lot of high resolution detail. Drones requires a bit more work to get the data together, to stitch it together effectively, but very powerful tool, and we've done some work with drones for sure.
Fantastic.